Good morning, good afternoon, and good evening. I mistakenly had the microphone muted, so I'm doing a voiceover. I have here a Denmen power bank, which was given to me about a year ago, defective. Here are the specifications. And so I will attempt to fix it in this video. Like I said, I diagnosed it about a year ago, and I had written some notes. It had an A19T P MOSFET that was blown, and I have a picture of that, and I'll put it here somewhere on the screen. It also had a W332 IC that was defective. I don't remember what was wrong with that. I assume I did some short testing, and I possibly found a short there. Anyway, so I've acquired both of these components and will attempt to replace them in this video. So let me show you where the transistor was. And here you can see, let me zoom in. So this is where the transistor was that was blown. And so I will begin by soldering on a new transistor. Okay, I'm going to add a bit of flux. And as you can see, I've used some aluminum tape to cover some of the connectors, because I don't want to melt any plastic. I'll be using the hot air at 350 degrees Celsius and 50% airflow. Here we go. First, I'm getting the area hot, and then I'll wait for the solder to be molten, and it'll get a bit shiny. I'm grabbing the component with the tweezer, and now soon, there you go. Now the solder is molten. I'm trying to place the component, and whoa, it flew away. Thankfully, I was able to save it. And right there, I'm struggling, you can see in the corner. I'm struggling to try and get it back. And I'm actually right now reducing the airflow from 50%. I believe I reduced it to 25%, 20 to 25%. And trying again. Again, waiting for the solder to molten. And I think we're almost there. There we go, and I'm placing the component again. And that time it didn't fly away. Now making some adjustments. Pushing the component down to make sure that it's flat, and I'm removing the hot air. And I'm going to keep pushing down, and now I think the solder is solid. So that's the transistor done. And now we have to move to the IC chip. But before I move to the IC, I'm gonna do a bit of a cleanup on the board. So all this time I had the microphone muted and I wasn't aware. Hopefully I'll do a voiceover for those parts. Anyway, so this is the chip, and I'm gonna tin it. I'm going to thin the pads. Supposedly that helps. I don't know, but I'm going to do it. My microscope just froze. I'll be back. And we're back. Let me continue. Finish up tinning this chip. Alright, I think we're ready to install this chip. It looks like the pads are already prepped on this board. But let me see if I can reduce this size, or it's not worth it. No, I guess we can go ahead without doing anything. Alright, I'm gonna add a bit of flux. And I'm gonna use the same temperatures as before. Now we have to keep in mind this is the indication of pin 1. There's this dot, and there is a dot on the chip also, right there. So they have to match. Alright, I'm going to start by heating the board a bit. So again, it's 350 degrees Celsius at 20% airflow. Okay. I'm going to add some more flux and try to flow it into place. I'm going to increase airflow to 40%. Now going back to 30%. Oh, I dislodged. Okay. Yeah, I think it snapped into place. Yeah. Okay, taking the heat away. While the board is still hot, should I go over to the soldering iron? Yeah, why not? I'll add a bit of flux and go over to the soldering iron. Alright, time for a cleanup and inspection. And now we can do our inspection. That looks good. Next side. That's not too bad. Next. That's pretty good. I'm gonna check on this last pin here after. Okay, now this side. That's looking good also. A few pins I will double check also here. Alright, let me check on those and I'll be back. So I did a second reflow of the chip and pushed down on it just to make sure that it's flat to the board. And this is what it looks like now. This is the first side. This is the second side. Third. And finally, we have the fourth side. I think that's pretty good. So we're gonna go with that and hope for the best. So I did some checking for shorts or any damaged resistors, and I couldn't find anything wrong. So I think I'm going to move on to soldering on the battery. There's a B plus and a B minus, so I'm going to go ahead and solder the battery, and I'll be back. It's this battery here, and it shows also on the battery a plus and a minus sign right there, plus and minus. The battery is now soldered on. This is what it looks like. Not the prettiest thing, but it's on. Alright, I'm gonna put it back in the case, reassemble it, and then we'll do a test. So before I clip it shut, I decided to run a test to see if it actually works. So here we go. We're gonna do it together. Unfortunately, I don't have the button for the on-off here. There's like a plastic button for the switch. I lost it, but what can you do? Okay, here goes nothing. No, this didn't come on. I wonder if we need to press that button. Let me see. Well, something is blinking here. What does that mean? But there's no output. the USB meter is not coming on. So I think this is a failure. Let me plug in the USB cable, see if it will charge. Okay, I have the cable now. Let's see if it will charge. Well, look at that. We have 3 lights. I mean, the third one is blinking, meaning it's charging. But I wonder why I'm not getting. Try again. Ah, now it came on. 5 volts, 0 amps. Okay, let me connect. Let's see, I'm gonna charge. I have a desk fan. Come on. There we go. Alright, I'm gonna connect it to my desk fan and we'll see if it draws. Oh, it turned off. So is it gonna come on by pressing the button or? Ah, yes, now it's working with the button. Actually, I'm gonna wait for it to turn off and then I'm gonna plug it into the fan. I want to see if it comes on by itself. Okay, it's off. And I'm gonna plug it into my fan here. No, it didn't come on. So let me press the button. Yeah. And I have the light. It's charging the battery of the fan, and it's drawing currently 190 milliamp. Okay. I'm gonna also test. What am I gonna test? There is a micro USB. I assume that one is for charging the battery bank. So let's test that one. Here we go. Yeah, it's blinking, and it's charging with 5 volts at 350 milliamp. I assume USB-C charges at a faster rate. Okay, so 350 on micro USB. Let me connect the USB-C and I'll tell you what value it shows. Okay, USB-C is charging at 9 volts, 1.5 amp. So 14 watts, around 14 watts total. So it's much faster. I guess the only thing left to test is USB Type-C out. So I'm gonna plug a USB-C, dual USB-C, and let me find something to charge and I'll be back. Alright, so I found an old phone that has a USB-C in. So here we go, we're gonna use this tester because it has this meter, because it has USB-C in. Okay, and then I'm gonna plug it into the phone. Here we go. 8.9 volts at 1.5 amps. Let me show you. So 8.9 and 1.4 amps, and the phone is charging. Let me show you that. There's the red light showing that it's charging. So this has been a success. I am actually quite surprised and happily surprised. So now I can snap the case shut. I'm going to use a bit of hot glue on the bottom of the case because all the tabs broke while I was opening it a year ago. So I'm just going to add a bit of hot glue here and then push it closed. I have some clamps. Okay, I kept the clamps on for a few minutes and it sealed quite nicely. There's no give, no play. Alright, we're going to do a final test. I'm going to use my phone again and charge via USB-C. Okay, lights came on and 8.9 volt at 1.4 amps just like before. You have two lights and one green. And then it's starting 8.9 at 1.4. Alright, well I hope you enjoyed this video and see you on the next one. Bye bye.